Welcome. Today we're going to learn how to graph a quadratic in standard form. To start with, we're going to go to our little graphic organizer that we have that identifies all the pieces of a quadratic in standard form. The equation for standard form is y equals, or f of x equals, ax squared plus bx plus c. As always, the a is our factor. It tells us whether it opens up or down. If a is positive, it opens up. If a is negative, it opens down. To find your axis of symmetry, though, it's done a little bit differently. We actually have to use an equation for this one. It's x equals negative b over 2a. Once we have our axis of symmetry, we take it and just like before with intercept form, we take our axis of symmetry and we substitute it in for x and we solve. And that will give me my y value. We also know as our k. Remember, our axis of symmetry, even though we refer to it as x, is actually our h value. To find the intercepts, the only one we're going to really worry about right now is how to find the y-intercept. To find the y-intercept, you're going to let x equal 0 and you're going to solve. Other coordinates you can make a table on, which we can do. Also, we also talk about the maximum or minimum. Remember, it has a maximum if a is negative. It has a minimum if a is positive. And it's whatever that k value is that we calculate. So that should complete your graphic organizer for all the different parts we know right now. So now what we're going to do is we're going to put in an example. So the example we're going to do is f of x equals negative x squared minus 10x minus 26. As always, a is the leading coefficient in front of your x squared. In this case, it's a negative 1. So a equals negative 1. Now, unlike before, we're going to make sure everything's in standard form, which means it goes x squared, x in constant, which it does. And we're going to list our other values. So b is negative 10, and c is negative 26. Now, a being negative, we know it opens down, which is nice. We first need to find our axis of symmetry. So we're going to use that equation that I gave you, which was x equals negative b over 2a. So we're going to say x equals a negative 10, make a positive 10, over 2 times a, negative 1. Well, that's 10 divided by negative 2, which means x equals negative 5. So our horizontal translation is we're going to go left 5. At this point, we're going to draw in our axis of symmetry at x equals negative 5. Now we have to find out where our vertex is on that line. We know it's negative 5 comma something. So we're going to put negative 5 in our math problem. So we're going to find f of negative 5. To do that, everywhere we see an x, we're going to put in negative 5. So negative 5 squared is 25, but the negative on the outside is going to assign a negative back to it. So it's negative 25. Negative 10 times a negative 5 is a positive 50, which basically gives us 25. Minus 26 more is going to be negative 1. So f of negative 5 is negative 1. So here is my vertex. Once I have that, you can create a table. We use our transformation to help us out. We're going to transform it by moving it one right and one left. So we square those numbers, which is 1, and we multiply by a, which is negative 1. I'm going to do the same thing with 2. 2 squared is 4, times negative 1 is negative 4. Remember that the middle is unneeded, so we get rid of that. So from my vertex, I'm going to go right 1 down 1, and I'm going to go right 2 down 4, and I'm going to reflect that across my axis of symmetry. Then I just draw my quadratic or parabola in, and I put arrows on the end. As you notice, this does have a maximum at y equals negative 1. So let's try another one. It says example 1, but really it's example 2. The equation is x squared minus 6x plus 11. Step 1, we make sure that it is in standard form, which it is. We identify our a, b, and c. A is 1, b is negative 6, and c is 11. We're going to plug it into our equation. X equals negative b over 2a to find our x-axis of symmetry. It will also give us the x value in our new vertex for our transformation. So we do x equals negative, and we put in a negative b, so it becomes 6 over 2 times a, so 2 times 1. 6 over 2 times 1 is 2, so x equals 3. So then, using my tools, I'm going to draw an axis of symmetry at x equals 3. Once I have my axis of symmetry at x equals 3, I'm going to take my function f of x and put a 3 in. So it's going to become 3 squared minus 6 times 3 plus 11. 3 squared is 9. 6 times 3 is 18 plus 11. 9 minus 18 is negative 9 plus 11 is positive 2. So my vertex is at 3, 2. So I plot my vertex at 3, 2. I make my small table. I pick a couple values for x. I square those values, and then I multiply by the a value, which is 1. 1 squared is 1, 2 squared is 4. Anything times 1 is just the identity property, so it's 1 and 4. The middle is trash. So, oh, wait, that should have been at 3, 2, which it is. So now we're going to go right 1, up 1. We're going to go right 2, up 4, and we are going to reflect it. We'll sketch in our parabola, and we'll draw our arrows. Now, if you wanted to, you could find your y-intercepts, even though it wouldn't fit on this graph. All we would have to do is plug 0 in, which would give you 0 squared minus 6 times 0 plus 11, which just gives us that constant of 11. So when things are in standard form, the y-intercept is actually just the c value. Let's try another one. 2x squared minus 4x plus 5. First, we make sure it's in order, which it is. My a is 2, my b is negative 4, my c is 5. I plug it in my equation. Now, is b always going to be negative? No, just the problems I picked started this way. So x equals negative b, so 4 over 2 times a, 2 times 2. So we get 4 over 4, which is just 1. So I draw my axis of symmetry in at 1. I take my function and I substitute 1 in for x. This is where the majority of you will make mistakes. It's not so much plugging in the number, but doing the order of operations correctly. You always do exponents first, so 1 squared is 1 times 2 is 2. 4 times 1 is 4, plus 5. 2 minus 4 is negative 2, plus 5 gives me positive 3. So I put in a 1, I got a 3, so my vertex is at 1, 3. So I plot it. I create my table. I pick a couple of x values. I square them. And I stretch my graph by a factor of a, which is 2. 1 times 2 is 2. 4 times 2 is 8. So from here, we're going to go right 1 up 2 and right 2 up 8. 1, 2, 3, 4, 5, 6, 7. Just slightly above on my graph. We're going to sketch in our quadratic, which creates that parabola, and ta-da, we're done. Now let's talk about special scenarios. Okay, what happens when I have 3x squared plus 12x plus 12? Realizing that it's probably going to be a little bit stretched, so be careful when you pick your values, because you don't want to pick too big of values, because too big of values will create a very large graph. So for example 3, we'll do A is 3, B is 12, and C is 12. I do x equals negative b over 2a, which gives me negative 12 over 6, which is negative 2. I draw in my axis of symmetry. A little off there. I take my value and I plug it in. Negative 2 squared is 4 times 3 is 12. 12 times negative 2 is negative 24. Plus 12, well 12 minus 24 is negative 12, plus 12 is 0. So even though I started with big numbers, I didn't end with big numbers. So negative 2, 0. So sometimes your vertex will be actually on the axis. Create my little table. Pick my numbers, square my numbers, multiply by my a value. So we end up with 3 and 12. So we probably won't be able to fit the 2, 12 on there, but we can go 1, 3, 1, 3, and reflect and sketch in our graph. Hopefully this has been helpful. Same case anytime you have any type of problem. This is example 4. We're going to kind of skip that. Example 5 is where we're going to end. It says f of x equals negative 1/2 x squared plus 4. Now if you look at this, you could think, well, that's in vertex form, so I can just graph it that way. Well, yeah, you can. Nobody's stopping you. But if you want to use the same form on each, a will be negative 1/2 in this. B will be 0 because there is no x, and C will be 4. Now I like this one because it has a fraction, and we haven't done a fraction yet. So we're going to do x equals negative b, so negative 0 over 2 times negative 1/2. Well, negative 0 is just 0. 2 times negative 1/2 is negative 1, and 0 divided by negative 1 is just 0. So sometimes your axis of symmetry will be the actual x-axis. We're going to plug in 0 into our function, so f of 0 equals negative 1/2, 0 squared plus 4. 0 squared is 0, times negative 1/2 is 0, plus 4 is 4. So my vertex is at 0, 4. I plot my vertex at 0, 4. I create my table, and I multiply by my a value. Now we've talked about this sometimes with fractions. Sometimes it's helpful to pick multiples of the denominators. So I'm going to pick 2 and 4 this time. 2 squared is 4, and half of 4 is 2, but it's going to be a negative 2. 4 squared is 16. Half of 16 is 8, but it's a negative 8. So from my vertex, I'm going to go 2 right and 2 down. The benefit of using factors of the denominator is that sometimes it will give you nice, pretty, ordered pairs to plot. We're going to go 4, -8. We're going to reflect it and draw in our quadratic. In this case, it has a maximum. If you notice, the end value is 4, which is my y-intercept. It is also my maximum, in which is y equals 4. I hope this has been helpful in learning how to graph a quadratic in standard form. Have a good day.